You're welcome to FUNNYMATH. As our students prepare for the upcoming BECs, wish them the best, their first standardized examination that they're going to write. Now let's begin with the questions. The questions are many, so have time, relax, sit back, and let's see how we can go through the questions. Now this is the first question. That's question 1A. Musa needs to earn an average of at least 80 or 3 test scores in an examination. He scored 75 and 86 in the first 2 tests. If X is the score Musa will earn on the third test, write an inequality to represent this situation. That is the question. We have II. What is the minimum score Musa must have on the third test in order to earn an average of 80? So let's begin with the first one. Now, let's get some important information from the question. Musa needs to earn an average of at least 80. So let's get the meaning of this keyword, at least 80. Now, when we say at least 80, it means Musa should get 80 or above. So the average should be greater than or equal to 80. You have to know the meaning of this, keyword, that is at least. Now, this average that we are talking about, the same as the mean. What you have to know is that the mode, the median, and the mean, they are all averages in terms of, statistics. They are all averages. When we use average, we are actually referring to, the mean, even though the other ones are also, averages. Now, let's move on. So in the first 2 tests, he scored 75 and 86. We have 75. I'm working question 1AI. So we have 1AI. Let me get that one here. So I have to shift this one here a little bit. So he had 75 and then 86 in the second one. And the third one was given in a question. If X is the score Musa will earn on the third test, that means X is going to be the score for Musa in the third test. You have to write an inequality for this one. Now listen. At least 80 means greater than or equal to 80. How do we connect this one with the average of these 3 numbers? To find the average of these 3 numbers is going to be this. So the mean or the average is going to be 75 plus 86 plus X divided by the number of, test items. And that's going to be 3. So the first test, the second, and the third one. So we have 3 here. Now, this average should be at least 80. That means greater than or equal to 80. So this is what we are expecting. Now we can simplify this one, 75 plus 86, and that's going to give me 161. You can verify. So plus X out of 3, and that is greater than or equal to, 80. So that's the inequality that we are talking about. So we are done with the first one. That is very, very easy, right? Now let's move on to the next question. What is the minimum score Musa must have on the third test in order to earn average of 80? So that means we are going to find the value of X. Oh yeah, we have already said that for Musa to, achieve his goal or aim, the average should be at least 80, and that is what we have done here. So if Musa wants to get an average of 80 or greater, what should be his score in a third test? That is what we are asking, in a II. What should be the range of scores that Musa should get? So we want the minimum score that Musa must get so that he is able, to achieve that goal that he wants to achieve. So that's going to be question 1A II. So let me get that one here, 1A II. So I'm just going to use this inequality. That is 161 plus X out of 3 greater than or equal to 80. So I'm going to find the value of X. Now, let's move on. So I have to find the LCM, and the LCM is going to be 3 multiplied through by the, the expressions, the terms of the expression here. So that's going to be 3 times into bracket 161 plus X out over 3 greater than or equal to 80 times 3. So this 3 will just cancel this 3. So we have 161 plus X greater than or equal to 80 times 3. 8 times 3 is going to be 24. So we just have to attach our 0. So we have 240. We are going to get X. We just have to subtract 61 from the other side. So we have 240 minus 161. So X is greater than or equal to 79. So that's the range of values that Musa should get for him to achieve his goal. So that is what you have to know. So the minimum score should be 79. So you can get 79, 80, 81, up to 100 for him to achieve his goal. And the goal is getting an average which is greater than or equal to 80. Therefore, the minimum score, so that's the minimum score, that's 79. He has to get 79 for him to achieve his goal. Let's move on to the next question. That is question 1B. We have 1B here. That is I, 1BI. Let me get a question. The data below shows the ages in years of 15 people. And these are the ages 19, 28, 29, 33, 27, 27, 37, 25, 27, 37, 17, 45, 47, 25, and 26. Now we have to draw a stem and leaf plot to illustrate this information. And after that, we use this information to determine the mode and the median. So first of all, you have to get the stem and leaf plot. Now that's very, very easy, right? So I have to get my stem here. So that's my stem. Now I have to get my leaf as well. So my leaf is going to be here. Now, everything is set. Let's go through the numbers that we have here. The ages that we have here. The minimum is in the tens column. We don't have any ones digits here. They are all in the tens column. They are two-digit numbers starting from the tens column. So now we can get one here. And now from that, we have the 20 column. So we have two. We have the 30 column. We have three here. And we have the 40 column. And that's going to be the last column. We don't have 50 column here. So now, let's get our values here right now. This is how we are going to do it. So I'm starting from 19. So I'll just have to circle it. So I'll write 9 here. I come to 28. So 2. So I'm going to write 8 here. We have 29. So that's going to be 9 here. We have 33. So that will be in the 30 column. We have 3 here. 27. So 27, that's going to be 7. We have 20, another 27, another 7. We have 37. So that's going to be in the 30 column. We have 25. So that's going to be here. We have 27. 7 is going to be here. 37. We have 7 here. Move on to 17. So that's going to be in the 10th column. So we have 7. We have 45. So we have 5 here. We come to 47. That's going to be 7 here. We have 25. So in the 20 column. 26. Still in the 20 column. So we have 6. So that's the stem and leaf plots. We are actually done. But let's see something. We are going to use this information to find the mode and the median. So it is better to rearrange this data, in order, in ascending order. That is going to help you a lot. So that we can easily find the median. Because at the moment, if you try to find the median, you're going to get, a false median. Oh yeah, you're going to get a false median, which is wrong. So you have to rearrange so that you get the median and the mode. So now, let me do that here. So I'm going to get my stem once again. I have to get my leaf. So here's going to be my leaf. We have the leaf here. Now rearranging is very, very simple because we have the information already. So we have 1. Let me do it out of 1. So that means, we have 19 and 17. So 7 should come first, and then 9. That's very, very easy. So we come to 20 column. So we have, 5. That's the least. We have 5. The 5s, they are 2. So 1, 2. So another 5. We come to, we don't have, 6. We have 6 there. So 6 is just 1. We come to, 7. We have 3. We have 7, 7, 7. And now we have 8. Excellent. 8. And we have 9. Let's come to, the 30 column. It has been arranged already. So we have 3, 7 out of 7. The last column, that's going to be 4. The 40 column. It has been arranged already as well. We have 5, 7. So that is our stem and leaf plots. This time arranged in order of size. So now we can find the mode and the median. That is question 1BII. So first of all, let me find the mode. So the mode is the most appearing number or data. So when you come here, so the mode is going to be, that's obviously going to be 27 because 7 is appearing here, 3 times more than any other figure. So that corresponds to 2. So we have 27 as the mode. So the mode is 27. Now let's come to the median. Remember, they are all parts of the question 1BII. So let's get the median. The median is the middle number. Now, we can easily just do cross-cutting. Back cutting. Just cut one here, cut one here, cut one, and then we get a middle number. You can use that traditional approach. Also use a formula. And this is a formula that we can use to, get a median. Let me save this one here. So the median is equal to, you see, the total number of data, it was 15 as mentioned in the question, but we can just verify here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is 15. So this is an odd data. So the median is going to be one, number. We are going to get one middle number. Remember that when we get an even data, the middle numbers are going to be 2. Yeah, then we find the average of the two middle numbers. But for odd data, we get one middle number. So the formula is going to be half of, into brackets, n plus 1, th, item, or observation. So what do we mean by this stuff? That's very, very simple. So that's going to be half of n is going to be the total number of items, and we have 15. So that's going to be 15. So 15 plus 1. This th here is talking about position. So we're going to get half of 15 plus 1 is going to be 16. Th item. And half of 16 is going to be 8. So just attach this th, that's going to be 8 items. So that is it. You have to know this formula. This is for, odd data. Now, before we move on to find the median, let me give you the formula for, an even data. So we're going to get the median, even though that's not part of the question. I'm just trying to give you that one too. So that's going to be half of the total number of items, which is n. So we have nth and next item. So this means that, for example, assuming the median, the number of items is, let's say, 14. 14. 14 is an even number. So to find the median is going to be half of 14, that is n. So we have 14 th, and the next item, and half of 14, that's going to be 7th. So we have the 7th item, and the next item to 7th is going to be 8th item. So you see we are getting two middle numbers, the 7th and the 8th. So always whenever you get an even data, you will get two middle numbers. But for an odd data, we have only one middle number. So now let's go and look for this number. Remember, this 8 here is not the median that we are talking about. So let's go and look for that particular number. Let me clear this out from here. From this data, we are going to look for the 8th item. So let me start. So this is the first item, the second, the third, the fourth, the fifth, the sixth, the seventh, and the 8th. So that's the 8th item. Get it? So the 8th item corresponds to, this one. So that's going to be 27. So this implies that the median is equal to 27. So that is it. That's the median. But since you're talking about, ages, you have to bring the years, 27 years. So that is it. Now, in some contexts, you have to write a key, for the stem and leaf plot. So you can write key here. The key can be, let's say, 1/7 is equal to 17. So you're just trying to give, a scale for, the stem and leaf plot. So whenever you see 1/7, 7, it means 17. So that is how we can find the median for this one. Let's move on to the next question. So let's get the next question here. So we have question 1C, triangle ABC with sides AB. So this symbol means triangle. The sides AB 10 centimeters, BC 12 centimeters, and AC 16 centimeters. Is enlarged to triangle A1, B1, C1 such that the largest side of the triangle A1, B1, C1 is 24 centimeters. Now we have to determine the scale factor of this enlargement. Now, they didn't specify the type of triangle, but as you can see, this is going to be a scalene triangle. It can also be a right angle triangle. Yeah, depending on the size that we have here. So now, let me get my first triangle. So that's going to be here. So I want to use this one as my first triangle. AC is the longest side, so I'm going to use here as A, and here is going to be C. So here is going to be my B. So we have triangle ABC here. Now, AC is 16 centimeters. We have 16 centimeters here. BC is 12 centimeters. And AB is 10 centimeters. So let me get the next triangle, the enlarged triangle. So here is going to be A1. So this point corresponds to this point. So here is going to be B1. It also corresponds to this one. And C also corresponds to this one. So this is C1. So now, it was stated in the question that the largest side of the triangle A1, B1, C1 is 24 centimeters. So the largest side is going to be A1, C1. So that is 24 centimeters, according to the question. Now, we come to, the first question here. That is, we have to find the scale factor of the enlargement. So how do we find the scale factor? The scale factor is equal to the image length over the object length. So now when you say something like this, we are talking about, the corresponding side. So the length of image over the corresponding length of objects. So now, as you can see from the triangles here, AB corresponds to A1, B1. But we don't have the magnitude of, the side A1, B1. So that cannot be used. But with AC and that of A1, C1, all the information are there. So we can, use this information to find the scale factor. So the length of image, and the image is going to be A1, C1. So we have A1, C1 here. Now out of, we have AC. That's the side AC. So you just have to do substitutions. A1, C1 is going to be 24 centimeters out of, AC, that is 16 centimeters. We can just simplify. We can use A to, cancel out. It goes into 16 two times, and it goes into 24 three times. So that means that the scale factor is 3 on 2. Remember, scale factor has no unit. So the centimeters will also cancel the centimeters. So we have 3 on 2. So take note of that. So that's the scale factor. Now let's move on to find the length of the other sides of the triangle, of the enlargement. So you have to know the length of A1, B1. We have to also know the length of B1, C1. That's very, very simple because we know the scale factor to be 3 on 2. So to get the scale factor, the length of A1, B1, what are we going to do? So that's going to be question 1CII. So you have that one here. Let me get it here. 1CII. Oh yeah, that is II. Okay. So now we have to find the length of the other sides of the enlargement. So what we have to know is that whenever you multiply the scale factor by the object length, it gives us the image length. So you should know that, the 16, when you multiply by, 3 on 2, we are going to get 24. And that is obvious. 16 times 3 on 2 is going to give you 24. Because 2 here, 1, 2 goes into 16, 8, and 8 times 3 is going to give you 24. So that should tell you that when I multiply the scale factor by 10, it will give me A1, B1. And when I multiply the scale factor by 12, it will give me B1, C1. So that's the approach that I'm going to use here. So let me get A1, B1. So now the side A1, B1 is equal to AB times the scale factor times 3 on 2. That's the scale factor. So let me shift this one. And now we know that AB is 10. So you have 10 times 3 on 2. So 2 here, 1, 2 goes into 10, 5. So you're going to get 5 times 3. And that will give me 15. That means A1, B1 is 15 centimeters. So easily, you can also work B1, C1. So now B1, C1 is equal to, BC times the scale factor, which is 3 on 2. And BC, in the question, it is 12 times 3 on 2. So now 2 here, 1, 2 goes into 12, 6 times. So that's going to give me 6 times 3. We have 18 centimeters. So that's the length or the magnitude of the length B1, C1. Now let's get our last question. The last question is question 1D, and we have the expression 27 exponent neg1 on 2. So the negative sign is there, very, very small. So you have neg1 on 2, now equal to, 27 exponent 1 on 4, now divided by 3 exponent x plus 1. So that's the expression. How do we, find the value of x or the z value of x? So let's begin. So I'm going to make sure that they all have the same base because this is an exponential equation. Why? Because the exponent of this is a variable. And now we have the equal sign here, so it is forming an exponential equation. And whenever it comes to exponential equations, make sure the bases are the same. So let's see what we're going to do here. So now I'm going to express 27 in terms of 3. So now let's express this one in terms of 3. So I'm going to get 3 exponent 3. That will give me 27. But remember, we have an exponent of like 1 over 2 there already. So what happens to that one? We have to multiply by this one. So we have times like 1 over 2. Now equal to this one to the same thing. So we have 3 exponents. Now 3 times. We also have an exponent here already, which is 1 on 4. We call this one power rule. So 3 raised to the power 3, which is also raised to the power, neg 1 on 2. So the rule says that we have to multiply the powers. And that is why I've multiplied them. Now, divided by, I have nothing to worry about because the base is already 3. So we have 3 exponent x plus 1. So at this point, I'm going to simplify my exponents. So we have 3 exponents. 3 times this is going to be negative, 3 on 2 equal to 3 exponent. 3 times 1 on 4 is going to be 3 on 4. Now divided by 3 exponents x plus 1. At this point, we can simplify this side because we are dividing. So we have 3 exponent, 3 on 2 equal to. Now, the bases are the same, 3, 3, and now we are dividing. So the law says that we have to subtract their exponents since we are dividing. So we just take one of the bases, which is 3, then we subtract the exponents. So that's going to be 3 on 4 minus, x plus 1. That's a binomial. So this is what we have here. Now, at this point, we have, this side being equal to this side. And now the bases are the same. So we just assume that the exponents are also the same. So that's what I was just looking for. We have to make sure that the base on this side, the same as the base on this side, then we just have to equate the exponents. So now let me do that here right now. So this implies that neg 3 on 2 is equal to, 3 on 4 minus x plus 1. So that was what I was expecting. And now we have it. Now we can find the value of x, a normal equation. So I have to find the LCM to do away with the fractions, and the LCM is going to be, 4. So the LCM is 4 here. We multiply 4 by the term that we have here. So that's going to be 4 times negative 3 on 2 equal to 4 times 3 on 4 minus 4 times x plus 1. So that is what we have. So let me continue from this side. We can simplify, 2 here 1 goes into 4 2 times. 4 here 1 goes into 4 1. So now, let me get what I have here. Let me write it here. Once again, I just want you to follow the steps. We have 2 times like 3. Now, equal to 1 times 3. So that's going to be obviously 3 minus 4 multiplying x plus 1. So 2 times negative 3 is going to be negative 6 equal to 3. Now, let's expand this side. Negative 4 times x is going to be negative 4x. And negative 4 times, positive 1. That will give me negative 4. So we can still simplify this side. So we have negative 6 equal to, 3 minus 4, negative 4x, which will give me negative 6 equal to negative 1 minus 4x. So now, I can just take this neg 1 to this side so that we get neg 6 plus 1 equal to 4x. And now neg 6 plus 1 is going to give me neg 5 equal to neg 4x. Now we want the value of x, so we have to divide here by 4, neg 4, here too by neg 4. So this one just cancel the whole of this. And now the negative sign also cancel this negative sign. So we have 5 on 4 equal to x. So that's the exact value of x.